Today I'll talk about human factors engineering and how you integrate this into your product development. Human factors engineering is basically fancy terminology for user research and the way it's done for medical device development. And I know it's late, so I'll try to keep this very interactive and very animated. So my name is Lázló Deli. I'm a senior innovation manager at Pilotfish. I specialize in medical device development. I built our quality management system, and I'm the quality officer of that. And I also lead our human factors engineering efforts. You've already heard a bit about Pilotfish. We are a design and innovation agency. One of our focus areas is the medical device development. And we have an integrated approach with human factors engineers, but also interaction designers, industrial designers, mechanical engineers, and production experts working together in projects, which we think is one of our key strengths and about which I will also talk a bit about during the session. And we have been focusing on human-centered design in the past 25 years. So during this session, I'll start with around 10 minutes of presentation in the beginning. Then we form groups. We've already done that, so that's perfect. And then we will design the worst possible product that you can come up with as an exercise. And then we'll present it to each other, pick the absolute worst of the three products that you'll design. And then afterwards, in the end, I'll reflect a bit how not to orchestrate a catastrophe when you're developing a product. So let's jump right into it. First of all, I already introduced human factors engineering. So the FDA, the American agency that certifies medical devices on the market, basically defines it as the approach for user research that ensures that you minimize related risks, and you also do it in a way where you provide evidence of the process that you have been doing. So basically this helps you to minimize user errors in a systemic manner, and through that you make safer, more effective, and also more intuitive devices, which is not every time the case if you look at medical devices these days. It also accelerates regulatory compliance because you produce the trace of the process that you need in order to certify the medical device. And it also, if you do it properly, it allows cost savings because there's nothing more expensive than a recall of your medical device if you messed up something and then on the field you figure it out that it's not safe to use on a day-to-day basis. And of course, through making better products, you improve patient outcomes and you improve the life of the people who use these devices on a daily basis. At least this is the idea, but if you look at how this is actually delivered, it's not flawless on the market. So we'll look at a couple of bad examples and what they teach us. And this might seem a bit basic from a certain perspective, but don't forget these are products that huge companies have produced, delivered to the market, and figured out that it doesn't work and then failed drastically with them. So first of all, there's this infusion pump, which is quite a high-risk product. So it's important to make it safe. It was made by Baxter, and they managed to make it so safe that it was flooded with alarms. And because it had so many alarms, there was alarm fatigue by the nurses, and they ended up rather just turning off the alarms to not be alarmed the whole day. Now you can imagine from a safety perspective, this is not really great. It's a device that passed the certification and it's considered to be safe, but it's not really a sane device. And many times when you look at products, and okay, it's back, you see that people look at the FDA guidelines or the certification requirements as basically a Bible that they have to follow and have to do the absolute minimum to be able to get on the market. It's a high risk and a difficult product development process to develop medical devices. So people try to cut corners here and there and try to just handle these activities as a checkbox of how do I must deliver. And this is really a critical mistake that results in very insanely bad medical devices on the market. Now, a second example that I brought is this wheelchair, which helps people with disabilities to get from A to B by propelling it through their arms. And you would expect it to not cause further disabilities to the users and not break their fingers as they are propelling it, which was not the case with this Medline wheelchair, which had to be recalled because it had the potential tendency of breaking users' fingers. And if you think about it, it's not a very complex thing to think about, okay, I have to pay attention to this because people's fingers are there. But many times when people make these projects, they don't really build the right foundations to build on. So they don't properly explore what the user needs are, they don't properly explore what the situation is, and they cut corners to make it simpler, make it faster, make it easier, and then they also simplify user research, because why to do expensive user research with the actual target audience when I can just invite my friends over and see if it works well or not. And obviously in medical device development it's not the friends, but it's very often not also the actual target audience that you are looking at. So this can be also very impactful for products. Now this third product is eventually a needle that you use during cataract surgeries. And essentially this was recalled because if you improperly assemble it, plastic pieces will break off the wrench and they might end up in the patient's eyes, which is a situation that is kind of multidisciplinary. You have to think about assembly, you have to think about how the product and the materials behave, and you have to think about usability, and then you have to combine all those things and evaluate your solutions from all those different angles. So it's really critical to not silo your teams and not have everybody separately working on their own thing, but try to make people come together and work together, because human factors engineering can't exist in a vacuum. And it's also really critical that you have very strong advocates in your teams whose responsibility is to ensure usability. Because otherwise, business perspectives or technical perspectives will overrule the needs of the user and the benefit of the user. Now, the fourth one is a glucose meter. And if you look at it, you might see 2.2 millimole per gram, you might see 22, and this already points to the direction of like, okay, this is actually then quite misleading if it's not entirely clear, even though it has the sole purpose of communicating this amount, and you can imagine a tenfold difference between the delivered amount is quite critical. Now, if anybody with a usability mindset looks at this, will immediately notice this is a bad design. But the thing is, if you notice it that it's a bad design, and then afterwards you don't document it properly, you don't communicate it to the teammates, and then you don't trace that actual improvements have been implemented related to it, then you might end up with issues that you even noticed in the meantime, but didn't solve in a traceable and consequent manner. And then finally, I have a Medtronic project with basically a surgical navigator system where a software glitch resulted in the system updating the localization. Now, if you use a surgical navigator, it basically helps you to connect where you are actually on the patient to your map, which is your imaging of where you are aiming to be or where you want to be, what you're aiming for. Now, if you reset your position at a certain point, the whole thing just loses its purpose and becomes extremely dangerous. And these kind of things can happen if, let's say, you develop your different product components on separate trajectories and you don't make a great plan on how to integrate these along the line. So maybe your software will be ready when your hardware is not, so integration is a bit postponed. or maybe they can update on the software, but that you don't integrate properly, and you end up with basically different trajectories of your development cycle that are not properly aligned. So it is really critical to ensure that you are on the right trajectory and that you plan everything together. So these are basically the 5 key pitfalls I wanted to mention to you to inspire you to basically design the worst possible product that you can come up right now. So basically what we'll do, we'll form groups. We already did that, so that's perfect. If you are joining in the back, then maybe it's better if you can join a table. Yeah, exactly. Otherwise you'll be a lonely group. And then, since we already have the teams, I just want you to assign roles. They'll be to have someone deliberately sketching at your table, someone who's the safety lead who will track the risks. I will explain what this means. I have one person, a scribe who writes. That can be a shared role with the designer. And then our presenter, that's the person who will in the end stay with your table and who will present to the others what you came up with. So give it 2 minutes and discuss internally within your team who's going to do what within your team from these roles.
Okay. So, who's the writer? Yeah? Fix the speaks. They're going yeah, who's the worst sketcher? Can you sketch? Probably not. You guess.
So we need someone who sketches, someone who will take the notes, someone who will focus on the risks, and someone who will present.
All right. So I cannot write. Oh, yeah, you can write. Okay, I know nothing about risks, so I can talk about that. Yeah, I'm a risk taker. I'm a risk taker.
Very good.
I always use the word risk.
I will then jump to the actual exercise, which will also help you to understand what to do with these roles, because eventually your assignment will be to come up with a plausible yet error-prone design. A product, and I will explain the use case in a second, that basically has very, well, as nice user errors and design errors that you can imagine in it. And basically your deliverables, what you have to do is you have to define a product description. So on the large papers that you have in front of you, make maybe a sketch of the product or describe it and include design error description also, you know, what the faults of the design are. And then you have the small papers, and those are your risk logs. There, collect as many risks as you can, risks or issues that come from those design flaws that you defined. Basically, these are the 2 things that you have to focus on. On the product description paper, also include a workflow. So the user uses it by first doing this and then that, etc. So explain the interactions, and then your use case essentially is a wearable EEG monitoring device that is designed for continuous neurological health tracking of elderly patients at home. So basically you can imagine old people with neurological issues or diseases that basically wear a wearable so that it keeps track of their EEG data, and it's a wireless device, and they use it for home monitoring elderly patients, or maybe early detection of and therapeutic management for these elderly patients. Now this is broad, so you can specify a bit the use case and come up with how can this be a horrendous product. So you can jump right into it, and then you will have 15 minutes. I will let you know every 5 minutes how much time is left. Then everybody can sit back on their place, and I basically wrap up in the following 5-10 minutes with now that we discussed how to do this very bad, quickly also take a look on how to maybe do it a bit better. So I will reflect a bit on on the project, and then give you some tips and tools and tips on how to improve and prevent such a catastrophe. So first of all, when you think about safe but not sane devices, something that you mentioned there was the 100-page instructions for use. And that's actually very common, that you have instructions for use, especially for medical devices, where you try to cross the risks by mitigating them, by saying, oh, no, you shouldn't do that. And then you end up with like a 100-page manual. And this is very often when things go safe but not sane, because no one will read it, because everybody's overwhelmed by the amount of information that you're communicating. So it's important that you should put usability as one of the core principles into your development, and not just ask, you know, can the user do it, but also how easily, how reliably, and how intuitively can the user do it. And those things help a lot. And when you do testing, really try to make real-world scenarios. So if it's a device that is used in a stress situation, actually use it in a stress situation and try to freak the fuck out of the people that you're testing with first, and try to go to user testing like that. With the foundational issues, it's very important to define what your product is and to clearly understand what the user needs are. Often people assume the user needs because maybe one person in the team is a subject expert, and then you think everything is already known from the users and you basically cut the corners here. But this is basically your anchor point where you set the direction of the product. And if here you're just slightly off, you'll start to walk towards the wrong direction. So really critical. And include checkpoints along the stages and try to figure out what to test when. The higher level, it impacts your product and your product architecture, the use of the product, the look, the build of the product. The earlier it's important to test, and the more tiny or minuscule the impact is, the more you can wait to fine-tune things. And in the beginning, if you see foundational gaps in your project, then mark it and really push for exploring those. When we think about siloed teams, it's very important to ensure that you create an environment where you enable cross-pollination, where you get people from different teams in the same room, and that you have central documentation that people can access and that they understand. So the use specifications and the goals, for example, are clear for everybody on the team, not just the use team, but also the engineering team is deeply integrating those into what they are trying to achieve. Do the multidisciplinary reviews as well. So review the work of engineers with usability experts, review the work of usability experts with engineers, and vice versa, and keep pollinating each other and inspiring each other instead of battling each other in the development. With the traceability gaps, this is quite medical device specific, but it's very important to basically have a very clear traceability matrix that links the outputs to the controls and the requirements. So basically, once you figured out something is wrong or something is very critical, make sure that you have a requirement related to that, and that later, when you have a requirement, you actually ensure that you test on that requirement, you pass that, and you make note of passing that, because otherwise you'll just end up with missed opportunities for improving your product. And same goes with the risk management plan. It's very important to start working on that and implement it from early on, and align the documentation tools. So whenever, let's say you do a user research, the way you collect the information, it's nice that you already think about how do you document it and how do you enable others understanding what you did. Because if you do great user research and then don't communicate it in a clear manner to the others, you will again miss opportunities of ensuring that things get implemented. And finally, it's all part of the plan. It's critical to centrally synchronize different product development trajectories and to ensure that, let's say, the hardware development and the software development are aligned and done parallel to each other, to prepare contingency plans and backups for situations that might go wrong and that are really critical for your timeline, and to trace basically the preparations closely. So yeah, basically those are my insights on how to avoid designing a wearable device where the battery is on the feet, but the device is on the head. Might make sense for some team members who are focusing on making it below a certain cost, because it's one of the goals to it. The device has to be below 100 euros, and then the decision makers, mere focus is on that, and you end up with something that potentially kills your users instead of helping your users. So yeah, if you're interested, I'll leave these on the screen. The first one is more light. No, the first one is a blog post from us, from Pilotfish. You can see it on our website. The second one is a lighter book about human errors and how these come in technology projects. Then afterwards, there are 2 standards relevant for medical device development and below the FDA guidelines that are also relevant for medical device development. So yeah, I hope you had a nice day and you enjoyed the workshops. Thank you very much for everybody. And if you would want to, if you have any questions, please feel free to come to me afterwards. Have a nice rest of the day.